So artificial intelligence. What is artificial intelligence? The only thing people in AI or anywhere can agree upon is the A part, the artificial part. That means non-human, it's inorganic, likely silicon. What about the I part? What is intelligence? Simone de Beauvoir, an existentialist philosopher, one of my favorites, says intelligence is a way of disclosing being. Silicon Valley says intelligence is a general-purpose problem solver. Are we just general-purpose problem-solving machines? I think not. So then what is intelligence? It's ambiguous. We can't answer it. And that's part of the problem. That's what leads to this confusion about AI, the hype about AI. What is AI? Is it a technology? Is it a tool? Is it a belief? Or is it just a bunch of hope? Well, I have a framework, and it goes like this. It's really, really easy to understand. It's very intuitive, and you will have a gauge for what AI is, what it's not, and what it can be, and what's beyond AI. It's very simple. All we'll be plotting here, it's a scale, and it goes from left to right. We're plotting how difficult things are for humans. And from bottom to top, we're plotting how things are difficulty-wise for computers, for machines. And this is plotted today, so it's a snapshot of what is possible today. And on the bottom left, yeah, these are things that's easy for humans, easy for computers, who cares about them, out. Bottom right, these are things that humans find difficult, but computers today find very, very easy. Things like manipulating large numbers, things like connecting people, marketplaces, optimization algorithms. Great. So let's jump to the top left, the quadrant called artificial intelligence. This is simply mimicking what humans can do naturally. So things like vision. A 3-year-old can pick out a cat or a dog or any other kinds of species that it has heard, or he or she has heard, in any storybooks without ever seeing that exact breed, type, or shape of animal. A machine today can pick out a dog image or a cat image, provided it's not really hidden, provided it's not in a forest, provided a lot of things, and provided it has seen it 1,000,000 times before, the training data. So that's where machines are today, but that itself is kind of amazing because with that, we can do huge possibilities. Another narrow intelligence application, moving, locomotion. This is where the robotics comes in. Yeah, moving in space, manipulating things. Maybe I should lift that, yeah, just to show what I want. So, okay, this is a quadrant of artificial intelligence. All we're doing here is mimicking human intelligence, and the reason for this is because we don't really know what intelligence is. There's no definition. No artificial intelligence researcher or scientist, philosopher, cognitive scientist, neuroscientist has a standard for us to compare things to, and that's why we have the Turing test. The Turing test simply compares if a machine is as intelligent as a human. Rather, can a machine mimic a human? And that's why that's a standard. But it's a little bit flawed, right? Because if we only compare intelligences to something that looks, talks, and feels like us, well, first of all, we can talk about whether that's a fair comparison. There are other types of intelligences, because intelligence is not a one-dimensional parameter space. There are other types of intelligences that we're used to just in the human arena, but beyond human. And that brings me to the quadrant on the top right, amplified intelligence. What if we create intelligences that are different from humans, that can empower and superpower humans? Computers are very, very good at manipulating complex information, remembering complex information, and pulling out complex patterns. Things that humans are not really good at because we were evolved, we were designed in a different environment, designed to solve different problems. So what if we can augment? And what does this quadrant called amplified intelligence look like? Problems here include things like drug discovery, which is a computationally very challenging approach. Very complex computations have to go into it. Automating science, that's a possibility. and predicting black swans. Black swans refer to rare events that are unpredictable, but rather obvious in hindsight. It's coined by Nassim Taleb. And today we'll dig a little bit into this. But first, the morphology that you draw upon to build these algorithms, whether you're in the quadrant of AI or in the quadrant of amplified intelligence, really matters.